This video is talking about quadratic functions that are in vertex form. The parent function of a quadratic is y equals x squared. This is any quadratic, and then it is transformed from x squared based on where the vertex is located and if it is being stretched or compressed or reflected. So vertex form actually tells you the transformations that's happening. Vertex form is written in y equals a parentheses x minus h parentheses squared plus k. Now these are two different letters that we haven't seen yet. We've used the m and n for intercept form, and we have the a, b, and c for standard form. We still have the a value, which is always in your quadratic functions. Your a value will always be there. So regardless of which function you're dealing with, vertex, standard, or intercept form, your a value will stay the same for all three forms. But the difference here is the h and k. Now, vertex form obviously will give you your vertex. Intercept form gives you your x-intercepts, and standard form gives you your y-intercept. So now we're figuring out how to find our vertex from the original equation. The vertex is actually given to you from your h and k. From your h and k. This tells you your vertex. This does not automatically tell you your intercepts, your x-intercepts, and it will not automatically tell you your y-intercept, but you can still find them if they have them. Now, all quadratics will have a vertex and a y-intercept, but not all quadratics will have x-intercepts because sometimes they're not factorable. So you got to make sure you're careful about that. We're always going to be able to find our vertex and our y-intercept. So the difference between this format and factored form is all multiplication. It has parentheses, but it's all multiplication. This still has a multiplication and it has parentheses, but it has a plus k at the end of the problem. It's not all multiplication. This becomes not intercept form, it becomes vertex form. This is also not in standard form because it has parentheses. If it has parentheses, it is not in standard form. Now, if we go down to this first problem, we have f of x equals x minus 4 squared. Because it's in the squared format, this will be vertex form automatically. As you can see, there's also not a plus k at the end, so this is also in intercept form. This does not happen often, but if there is only multiplication in here, then it is also an intercept form. What that means is that if there's no plus anything at the end, and this happens twice, that means that it bounces on the x-axis, which I have discussed in a previous video. Now, we still find our max and min, our vertex, our axis symmetry the same way we kind of always have. We're still going to find those. So our max or min, we still look at our a value. A is still always in the front. Since a is equal to a positive 1, we can see that we know that it will open up, and it will be a minimum value. That's still normal as we've done the entire time. Now, in previous videos, we always found our axis of symmetry before we found our vertex because we had to plug it back in. But because we're given the vertex form, we will automatically be given our vertex. So we can actually find that first. Our vertex is from the letters the h and k. H, as you can see from the original format, it says negative in here, but it has a positive here. What that means is h, whatever it is inside, is the opposite sign. But the k, if positive out here and it's positive here, you're actually going to keep the sign. So what I'm going to put here for our vertex is that whatever the h is, we're going to change the h. Change the h. We're going to change the sign on the h, but we're going to keep the sign on the k. So change h, keep k. So what that means, our h value comes from inside the parentheses. And if you notice, this is also with the x. So the h is the x value of your vertex because it's with the x. So our vertex right now is, we're going to change the h value. So right now it says negative 4. It's going to be a positive 4, comma. Now again, vertex will always be there, so we will have a k value even if we can't see it. Now, normally, if you don't see a number multiplied something, this would be a positive 1. But this, at the end, that plus k is not multiplied, it's added. So there is nothing added to the n. That means you're actually adding plus 0. So this is a 0. Your y value will be a 0. So our vertex is actually at 4, 0. The axis symmetry is still always the x value of your vertex. So it's that set x minus h equal to 0 and solve for x. As long as you have found your vertex, it is just the x value of your vertex. X value of the vertex, as always. So x is just equal to 4. Because our vertex was 4, 0. So we just take our x value. Now the difference here is we're not talking about our x-intercepts unless you can automatically find them. What we want to do is talk about the transformations of the original from the parent function y equals x squared to our new function. Transformations talk about going left and right, which is depending on the x value of your vertex, which is your h. It depends on the h. You can also go up and down, which is the y values, which depends on the k, because that's the y value of your vertex. Now we're also going to talk about stretching or compressing. Okay, stretching is when it's like really skinny. So if this is your normal parabola, stretching it makes it go really skinny. Compressing will make it go flatter. Okay, so it's actually wider. And then we're also going to see if it's going to reflect over the x-axis. If it stretches, it's because the a value, the absolute value, so just the value of it, is going to be greater than 1. A 1 keeps it normal. It's a normal parabola. But if it's greater than 1, say 2 or 3 or 4, it's going to make it go stretch and go skinnier. If your absolute value of a is smaller than 1, but it's still got to be bigger than 0 because it's got to be a positive, then that means it's going to go wider. Okay. Now we're talking about the absolute value because I just want to know the value of it. Because if it's a negative, that's when it reflects over the x-axis. So we're looking at a, we're going to find two things for the a value. Is it positive or negative? And then what is the actual value? And then that tells us our two different things here. It's either going to stretch or compress and reflect. So we're going to look for those from the a value. But then our left and right and our up and down determine we can only go left or right. We can't go both. And we can only go up or down. We can't go both. So if we're looking at our vertex, the h value is a positive 4, the y value is the k value is a 0, and our a was a positive 1. So we're going to write down those values. We're going to write down those things that we're looking at. A value is equal to a positive 1. The h value is equal to a positive 4, and the k value is equal to a 0. What that tells us, the h, left and right depends on the h. So h is a positive 4. If it's positive, you would go to the right. So if h is 4, h would tell us that it's going to the right 4 spaces. Since k is 0, it is not going to go up or down at all, so we don't even have to write that. There is no up or down. Now, the a value gives you two different things. The a value gives you two different things. We're going to talk about the a is a positive value. Since a is positive, that means that there is going to be no reflection. It's going to open up. Because if it's opening down, that's how you know it's a reflection. So there is no reflect. But the other thing we want to know is the actual number for the a. A is it was a 1. So the positive gives you something and the 1 gives you something. Since it is not bigger or smaller than 1, there's actually no stretch or compress. It's normal. So no stretch or compress. So it's just going to be a normal parabola. We still find our domain and range as we always have. So our domain is still negative infinity to positive infinity with open brackets. And our range is still, I'm going to put my comma in here. We know that the minimum value, since it was a minimum, going back to minimum, it was a minimum, so minimum value is equal to, it's still the y value of our vertex. Minimum value is still 0. So since it is opening up, that hasn't changed, it's opening up, so that's a positive infinity. So we have a positive infinity here. And then our minimum value was 0, so we'll go here. So we have a closed bracket and then an open bracket. Okay. So what we're really focusing on here is making sure we can find our vertex and then we can find our transformations. Now we can still find our y-intercept by plugging 0 in and finding our y-intercept, and that way we can graph it. Because we're only going to be able to truly find one coordinate just from looking at the function, we're going to actually find the chart of coordinates near the vertex so that we can graph as many coordinates as we can. Alright, so on this first problem, we have f of x equals parentheses x minus 1 squared plus 2. Now, because this is squared, this is going to be a vertex form, and because there's a plus 2, this is not intercept form at all. So what we want to do is find our vertex. We're going to find our vertex because this is vertex form. Our vertex is going to be at, we're going to change h. So let's talk about what our values are. We have a is equal to a positive. A is equal to a 1. Our h value is equal to, again, it's going to change the h. So change the number inside the parentheses to become the different sign. So it's going to be a positive 1. And then our k value, we're going to keep the sign on the k. So it's going to keep a positive 2. Our vertex comes from our h and k. So our vertex is 1, 2. Therefore, our axis of symmetry has to be x equals a positive 1. Notice I have not found the x-intercepts yet because I don't know if this is going to have x-intercepts or not. So we're going to wait on that until after we've graphed it to see if it's even going to cross the x-axis. And I can actually determine right now if it will. Because our a value is positive, we can actually say that it's going to open up. I'm going to go ahead and put that. Open up. And since it's opening up, we're going to have a minimum value. And therefore, our value is, again, the y value of 2. So we can actually fill out quite a bit of this before we even do anything with the function. Our domain is going to be negative infinity, comma, positive infinity with open brackets. And our range will be, we're going to have a, since it's opening up, we're going to have a positive infinity. And then our value is 2. Close bracket, then open bracket. Now, I can actually see that since our vertex is going to be at 1, 2, and it's opening up, it'll actually never cross the x-intercept or the x-axis. So actually, there will be no x-intercepts. Because if I were to put this back in a standard form, I would not be able to factor it. I would not be able to factor it. So what we need to do is we're only going to be able to find, we have our vertex, we'll be able to find our y-intercept by plugging in 0. But what we want to do is make a chart so we can have 5 coordinates. So we're going to make a table. I'm going to make a note up here, make a table of values around the vertex, and we're going to solve for y. That way we can get our coordinates. As I said in an earlier video, you can actually plug in any x value and get a y value out, and you can get a coordinate. Because they are functions of each other, if we plug in x, we will get an output of y. So for our table of values, what I'm going to do is I'm going to have x, y, and we know we want to try and have 5 coordinates total, so I'm going to have 5 spaces so I can have 5 coordinates. So I have 1, 2, 3, 4, 5. This is so we can write our coordinates. I want to make sure my vertex is in the middle because of my axis of symmetry. It's going to be in the middle. So I'm going to put my 1, 2 here for my vertex. Now beside my vertex, I'm going to write more coordinates. And using the x values, I'm going to use the x values because I can always have an x. I'm going to use the coordinates or the x values of, to the right of 1 is 2 and then 3. And then to the left of 1 is 0 and then negative 1. This is going off of like a number line. So what we want to do is find the y values for this. Now one of the great things about this is that because we're doing our vertex in the middle, and these are the same distance away from our vertex, that the value we get for these y's, so these y's will be the exact same, and these y's will be the exact same. because they're mirror images of each other, just like before when we talked about the mirror image of the y-intercept. So we really only have to plug in the 2 and the 3, or the 0 and the negative 1. So I'm going to focus on the 2 and the 3. So if I say x equals 2, I'm going to plug it into my equation. So y equals, parentheses, 2 minus 1 squared plus 2. 2 minus 1 is 1. Squared is still 1. Plus 2 is 3. So this y is equal to 3. So I can actually put 3 right here, because that's the y equal 3 when I had x is 2. That means that my y-intercept is also at 0, 3. So down here when it says y-intercept, I can go ahead and fill that in. 0, 3. Then I can go and do my next one of x equals 3. Now I could use x equals negative 1, but it has negatives in it. I really don't want to deal with negatives. So if x equals 3, I have y equals, parentheses, 3 minus 1 squared plus 2. 3 minus 1 is 2. 2 squared is 4, so this entire thing is 4. Plus 2 is equal to 6, so y is equal to 6. So wherever my x is 3, I can put 6 here. And therefore, this one should be the same coordinate, same y value as the negative 1. Now that I have 5 coordinates, we can graph them. And they're all kind of small, so we know we can go by 10 or count by 1, so our scale is good. So I'm going to go ahead and put the x and the y on our axis. X on the x-axis, y on the y-axis. I'm going to graph our coordinates. Now, obviously, I'm going to graph my vertex first, which is at 1, positive 2. And then I'm going to graph my axis of symmetry, because I always need to make sure I have those. Now, because it's opening up, that's how we know that it definitely will not cross the x-axis. So that's why we have no x-intercepts. Now, the other coordinates are at 0, 3, 0, 3, and then negative 1, 6 is on the left-hand side. And then we can see the mirror of that. So we have 1, 1. We have 1, 2, 1, 2. And those are the coordinates of 2, 3, and then 3, 6. I can go even further if needed, but we have our 5 coordinates, so we can graph our parabola. I start from the vertex, and I make sure I try and make it as nice as possible. And that is our graph. Again, we only found one true coordinate from our function, and then we used the values to the left and right of our vertex to find the new coordinates. And as always, we can graph this in our calculator. So y equals, parentheses, x minus 1, parentheses, squared, plus 2. And our graph should look the same. It opens up. We can find our coordinates, second table. So 1, 2 is my vertex. I actually want to make 1, 2 go to the middle of my screen. So I press up. You can see my 1, 2 is coming down some. And I want 1, 2 to be in the middle. And do you notice that these values, the 3, 3, 6, 6, 11, 11, they're all the same because they're the same distance away from the vertex. So it's symmetrical. So I could have gone to negative 2, 11, and then I could also have done 4, 11 if I had figured those out. This next one, we're going to do the same thing. So the first thing we need to do is figure out our A value, H value, and K value. So again, there's two things for our A value. The first thing is it is a negative. We also have A is equal to the 2. We want to see the actual number for it. Our H value, because it's in this format, this is vertex form, because it's squared, and then there's a number on the outside, so this is vertex form. This is not x-intercept form, because there is a minus 3 at the end. Since it's in vertex form, we take the opposite of our 2, so we change the sign, it becomes a negative 2. But our K value, we want to keep the sign, whatever is on that K value, so we keep that negative 3. So what that tells us is that our vertex is at negative 2 and then negative 3. Our axis of symmetry then is x equals negative 2. Now we can fill out everything, almost everything, because of our vertex, because the x-intercepts and y-intercept are the only things that don't come from our vertex. So it opens, because it's negative, it opens down. Because a is equal to a negative, it opens down. And therefore, that's a maximum. The value from that comes from our vertex of the -3. Our domain is still that parentheses, or open bracket, negative infinity to positive infinity, open bracket. And then our range, again, having the comma in between them. Since opening down, we're going to have a negative infinity, and that's always on the left, because that's our minimum. Then our maximum value is -3. So we have open bracket, close bracket. Now, if we can actually determine if there will be x-intercepts or not. So our vertex is at -2, -3, so it's right here. Then it's opening down, so it's going to come this way. It'll never cross the x-axis. So we can actually say that there are, in fact, no x-intercepts, so there are none. If there are some, we will find them, but if we can automatically tell that there won't be any, then we know they're not. I want to find my y-intercept, but I'm going to wait until I do my chart. So again, we're going to make a table of values around the vertex and solve for y. So make a table of values around the vertex, and then solve for y. So we're going to do the same way I just did it a second ago. We're going to have our x and y. We're going to have 5 coordinates. So 1, 2, 3, 4, and then our 5th one will go there. So sorry, x, y. We'll have 1, 2, 3, 4, 5. The one in the middle should always be your vertex because we wanted to go around the vertex. So the x of a vertex was -2. Then our k of a vertex was -3. Now what we want are on the x values, we want to the right of -2 and to the left. So again, on a number line. So going up from -2 would be -1 and then 0. And this will tell us our y-intercept. So once we get this, we can go ahead and fill in our y-intercept. Now to the left of our vertex will be at -3 and then -4. Just so you know, if your chart does not include the x of 0, you will need to find that for your y-intercept. These last two just happen to have our chart having the 0 in it. So now, as I said earlier, since these are the same distance away from the vertex, and these are too, then the y values here for those two will be the same, and then the y values here will be the same. So we just have to find 2 values. So you can focus on the -1 and the 0, or the -3 and the -4, or you can actually focus on, you can do the -1 and then the -4, but it doesn't really matter. I'm going to focus on the -1 and 0. So we have x equals -1. I have to plug it back to the original. Y equals -2 parentheses -1 plus 2 parentheses squared minus 3. And you can plug this into your calculator to solve. This is -1 plus 2 is 1. Squared is 1. Times -2 is -2. Minus 3 is -5. So this will be -5 right here. And therefore, the -3 will be at -5 as well. Again, you can just plug it into your calculator if needed. So we have -2 parentheses -1 plus 2 parentheses squared, and then minus 3. Gives us a -5. So we'll do the same thing with the 0. So x equals 0. So we'll have y equals -2 parentheses 0 plus 2 parentheses squared minus 3. So I'll go back up here and do the same thing. So -2 parentheses 0 plus 2 parentheses squared minus 3. We get -11. So this is equal to -11. -11, -11 here. So because I have 0 here for my y-intercept, I can put down here 0, -11. Remember, the x value of 0 is your y-intercept. So whatever this is, you can go ahead and put here. Now we're going to go graph this. And we do have one number that's bigger than 10, or technically smaller than -10. So I'm going to keep it as count by 1, so I'm going to go slightly off the graph when I graph these. So I have my x and my y. I'm still going to keep it counting by 1, so I'm going to keep my scale. First thing is my vertex, which was that -2, -3. And then I'm going to do my, as always, my axis of symmetry. So that vertical line that goes through the vertex, I'm going to label it as AOS, x equals -2. And now I'm going to go plot the other points. So I have -1, so -1, -5, and then 0, -11, so about right here. Then they should be symmetrical, so I should have here, which is at -3, also -5, -3, -5. And then this is 1, 2 away, so 1, 2 away. This should be at -4, -11, which is also correct. So -4, -11. Now you can see it's not going to cross the x-axis, so we do not have any x-intercepts. So now we can graph our parabola. I start from the vertex and connect my points. Start from the vertex, connect the points. Again, this is the vertex form, so vertex form automatically tells you your vertex, and you can fill out almost the entire chart just from your vertex and from your A value. So on the vertex form, you don't try and find your x-intercepts until after you've graphed them. And then if they do have x-intercepts, we find them and we can plot them and we can write them. But if they don't have x-intercepts, then it's none.